with us for another few minutes.
No worries, that's fine. And just while that's happening, I'll just welcome everyone to this special presentation that we have. Thank you very much for starting the recording. This is being recorded, especially for those who are unable to attend. We do know that we work across many different time zones. It's nice to see those of us joining from the States. Welcome, Bill. Good to have you. Nice time for you for a change, isn't it?
Yes, it is. Thank you very much.
Hideki, bless you, you are here as well. It is not a very good time for you, Hideki.
Yeah, but it's still manageable.
Yeah, we do our very best to try and find the right time for everyone. It's very difficult. It's quite late in some areas of Europe, quite early, especially in Japan and South Korea, yes, and with China. So welcome, everyone. I will say that this meeting will be 60 minutes, 60 minutes. So it will go, actually now we're at 59 minutes. And Jean-Michel, we do see your presentation right now.
Okay, perfect. Do you see the full screen? Sorry, do you see the full screen mode,
Yes.
or do you see? Okay, perfect.
We see full screen mode, and it's just very good. And if you're ready to go, I'll just pass over to you, Jean-Michel, and I'll let you introduce yourself, if that's all right.
Sure, that's okay. So, by the way, thank you very much, Gillian and Ayala team for having us today. My name is Jean-Michel Roussequ. I'm actually a Senior Director of Product Management with Qualcomm. I'm here with a couple of my colleagues, right? And I think what we wanted to discuss with you today was, 5G, 5G NR and 5G precise positioning for for ports, right? So, Shyamal, are you on? We don't have Shyamal. Kiran, do you want to do a quick introduction?
Sure. Yeah. Hello, everyone. I'm Kiran Mukaveli, also Senior Director of Engineering at Qualcomm. I'm part of the Qualcomm research team and I work very closely with Jean-Michel and Shyamal, especially around the positioning solutions that we offer, including some of the early prototypes and the commercial solutions that we're all working on right now. Really look forward to this discussion with all of you. Thank you.
All right. Okay, so what we have for you, and I think we have an hour, Gillian, right? So what we thought we would do is we have a bunch of slides. I think the presentation is probably going to take us, 30 minutes, maybe 35, maybe 40. I don't know if we should do Q&A at the end or if we should, do questions as we go. Either way is fine for us. Please let us know what you'd prefer.
Okay, thank you. We'll do the presentation as it goes along. I'll ask everyone to use the chat box to put your questions in, and feel free if you want to have a specific question to raise your hand. I will be watching the participants list for hands raised, and Jean-Michel, and I'll let you know if we need to break the presentation.
Okay.
But I do believe normally we would do a presentation with questions at the end. However, this is a very interesting topic, and I do encourage everyone to have conversation as we go along. But I am watching, and Shyamal has just joined, so welcome, Shyamal.
Great. Hey, Shyamal. Okay, Shyamal, can you hear us?
He's still showing muted on my screen here. So Shyamal, welcome. If you are able to, can you hear us, please? Just pop something in the chat box if you aren't able to speak. Just checking your microphone.
Hey, this is Shyamal. I was having audio issues. I seem to be able to hear you now.
Okay, great. Thank you, Shyamal. Do you want to do a quick intro? Shyamal, we just went through the Qualcomm side of the intro.
Sure. My name is Shyamal Ramachandran. Hello, everyone. I am in the modem product management team in Qualcomm. As a part of my responsibilities, I look at modem technologies, evolving standards, and plan features on our chipset roadmap pertaining to communications.
All right. Thank you, Shyamal. Okay, so we actually have three major parts of this presentation, right? So first of all, I'm sure many of you are not familiar with Qualcomm, so we'll do a very, very quick intro of who we are and what kind of company we work for. Then I think I'll hand over to Shyamal, who will cover 5G, right, from a from a standards point of view, and he'll talk about a number of interesting things. And then I'll take over and focus on, I think, what the the core of the presentation should be about, which is precise positioning and what is it that we could expect from a positioning point of view from 5G for the port environment. Right. Okay, so like I said, we are part of Qualcomm, right? So Qualcomm, I suspect many of you don't know us. We are an American technology company, right? We were established in 1985. We're based in San Diego, California. And what we do, we create semiconductors, software, and services related to wireless technology, right? So Qualcomm pioneered what's called CDMA technology way back when. I'm sure most of you are familiar with TDMA or FDMA, right? CDMA is code division multiple access, right? So it was introduced, back in the 1990s, right, for 2G, and it was adopted as a 2G standard. The standard was IS-95 at the time. And from that point on, we actually led the evolution of cellular technology from 2G to 3G and 4G, and of course now 5G. Lots of activity, lots of discussions on 5G, and also working in actually 6G. What we do, we develop products and software for smartphones, right? That was the original goal of the company, but we have expanded the scope to addressing additional devices. Now we cover smartphones, but also vehicles, as well as smartwatches, IoT devices, laptops, and connectivity devices like Wi-Fi access points and Wi-Fi clients, right? We have two main divisions, right? One is the chipset division. We all part of the chipset division here, and there is also a technology licensing division. Okay, so one way that you can look at Qualcomm is, hey, Qualcomm is a wireless connectivity company, but we actually a little bit more than this. We're also a computing company, right? So if you look at the connectivity side of things, right, we are involved in cellular connectivity, but also Wi-Fi, Bluetooth, CV2X. We'll talk a little bit more about what this is in a few minutes. We also work on the RF front-end components that allow us to provide actually an end-to-end solution. These things are very complex. There's a lot of bands to support. There's a lot of complexity in the end-to-end system. But we are also a computing company, right? We focus on CPU and GPU, right? These graphic processors and DSPs and AI processors and so on and so on. The other thing we've been working on is multimedia technology like camera, video, voice, display, etc., right? And of course, components. Okay, so I have not mentioned location technology, right? But location technology is a key part of what we do, right? We've been working on location technology for the past 22 years. We started with GPS. I think Qualcomm was the first to integrate GPS into smartphones, and we've evolved from GPS to supporting the additional satellite systems that I'm sure you've heard of: GLONASS, Galileo, Beidou, QZSS, and more recently Navic, right? So we've been doing this for quite a while. But from a positioning technology point of view, we also obviously work on cellular positioning, Wi-Fi positioning, dead reckoning, and many other location technologies, right? So okay, so one thing that's key to us is we are a global company, right? So we're working with pretty much all the wireless operators in the world, and we're working with all the infrastructure vendors, right? So supporting standard-based solution is very important to us, right? We are strong believers in standardization and standard, right? And you see we work with more than 200 global standards and industry organizations, right? I wanted to say a few words about 3GPP. I think some of you guys may know 3GPP, but probably not all of you, right? 3GPP is one of the key standards organization that we are working with, right? 3GPP is the industry standard bodies that create cellular technologies that began in 3G and subsequently evolved to 4G and 5G. This is a member-driven organization that relies on R&D and technology inventions, right, from its member contributors. The process to standardize new cellular technologies is very much collaborative, right? So, companies get together, right? They join the efforts, they submit contributions that are reviewed and accepted by the wider organization, right? So you see this slide, we show a number of key 3GPP statistics. I think the one that are they all pretty impressive, frankly. But when it comes to 3GPP releases, right, we are up to release 16 and now moving to release 17 of the release. So a lot of work has been done at 3GPP with wireless communications. Okay, so this is the part that I hand over to you, Shyamal, and we're going to talk a little bit about 5G, and then I'll take back to cover positioning.
Sure. Thanks, Jean-Michel. I'll request you to move slides as we progress through this material. Yeah. So 5G is the current generation of cellular technology that is being deployed globally. No surprise, sequentially after 3G and 4G, we are currently at 5G. But what's very noteworthy about 5G is the pace at which it has been adopted is simply phenomenal. I would go as far as saying, the heyday of 5G is not here yet. Several large operators in many markets have started deploying 5G, but they have quite a lot of runway ahead of them. Yet the pace at which 5G has been adopted by subscribers, by operators, by device manufacturers is truly amazing. We already see quite a staggering number of devices out there. We see quite technologies, which certainly are still present and will continue to be present for some time to come. But the pace with which the shift has happened to the use and utilization of 5G has been something that we as an industry haven't seen before. We can move to the next slide. So at a super high level, what is 5G and what motivated 5G, right? So you have to understand the evolution of technologies from 2G, 3G, 4G, and 5G in the context of what cellular operators worldwide. We already have been for the past few years in a world where many operators, if not most, are already offering all-you-can-eat data plans to their subscribers and seeing that a lot of their subscribers are in fact signing up for such plans, right? So from an economic standpoint for operators, roundabout now with the advent of 5G, it's no longer about making incremental changes to win over a few more subscribers here and there, because you perhaps already are dealing with all the subscribers you can and are perhaps serving subscribers with all their needs, which pretty much has risen to all-you-can-eat data plans. So what more do operators need to do in terms of increasing revenues, increasing their addressable business, etc. And that's where 5G kind of outshines the previous generations. Basically, from get-go, 5G has been designed with the intent of exploding the use of cellular technology and reaching all sorts of use cases well beyond smartphones, well beyond users making phone calls or browsing for regular nominal data on their handheld devices. And one big way in which 5G has done this is to create a standard that is capable of utilizing spectrum assets in a very, very wide range of regions. Not only do traditional spectrum bands that have thus far been used by legacy cellular technologies, not only do those get used in 5G, but newer spectrum bands, especially in the millimeter wave spectrum, those have been incorporated into the 5G portfolio as well. Now, this is noteworthy because typically such high spectrum in multi-gigabit range, we are talking about upwards of tens of gigabits in range. So we're talking about 25, 26, 28, or even more gigahertz spectrum. In this range, we have thus far, till the advent of 5G, not seen handheld devices, not seen regular commercial grade devices. So this was the first time anything such mainstream commercial tried to adopt spectrum assets here. And the reason for doing this was the availability of wide chunks of spectrum, which would then translate into super high bandwidths that all of a sudden don't look like incremental upgrades on top of what previous generations have achieved generation over generation, but something that is leaps and bounds better and can now start offering data at rates where totally novel use cases become possible. For example, things like XR or things like 100% reliance on cloud-based processing for all sorts of applications, be it graphics, be it gaming, be it crunching numbers for sophisticated simulations. All of these things would require very high bandwidths, and that's what embracing millimeter wave makes available. Another key facet of 5G, especially in the millimeter wave spectrum area, is the ability to turn around messages over the air interface in a very quick manner. Fundamentally, the technology that's used for 5G, much like 4G, is OFDMA based. However, the physical definition of the slot structure that gets used for OFDMA is such that turnaround times over the air interface for messages being sent and responses being received is super quick. Now that adds the low latency dimension into the mix, once again enabling use cases that have thus far been atypical and certainly have been unheard of in handheld devices. So with this combination of super high throughput and bandwidths and really low latency, what's happened is there has been a rethinking of what cellular networks can do. There has been fundamental redesign of cellular networks to not just meet average Joe subscribers on the street, but also newer segments of the ecosystem that have thus far been untapped, things like verticals and things like industrial applications. And that's where 5G's focus continues to be going forward. So the first incarnation of 5G that you see today deployed in many, many markets worldwide are already meeting the needs of typical users and user handheld devices. The evolution of 5G that we are working on within Qualcomm, that the standards are readily churning on a quarterly basis, those are all focused on expanding the ability of 5G into other verticals by further exploiting very high bandwidths and super low latency that the technology can offer. We can go to the next slide, Jean-Michel. So of these new verticals, the key application that 5G adopters worldwide are looking for is essentially what we all come to know as Industry 4.0. This is using wireless technology for various industrial applications, most typically associated with production and manufacturing type use cases where there is a need for very precise position determination. There is a need for very low latency command and control type message transmission. And at times, there is a need for very high volumes of data being pushed to certain types of devices. Think, for example, of a manufacturing facility where day in, day out, there are robotic arms doing precise manufacturing activity. But at the end of the assembly line, when the entire product is assembled and ready to be shipped out, there is typically a whole bunch of software that needs to be pushed into whatever product is being manufactured. If a typical car were to be considered, there is so much more than just the mechanics of the car itself. At the last stage, there is quite a lot of data that's pushed into the device, into the car, by way of things like telematics or infotainment software code base. So all of these aspects require advanced 5G technologies, and that's precisely where 5G is able to fit the specific niche of requirements and deliver what's needed. Key components that have been built into 5G from get-go have been things that are traditionally associated with wireline communications, things like time synchronized networking, for example, and naturally the ability to deliver near lossless, highly robust communication. So that's also something that has been brought into 5G by way of ultra reliable communications. Now, while Industry 4.0 and typical manufacturing are the use cases where these features are most associated, there are several ancillary applications that are coming up where similar considerations are key. For example, transportation hubs, be it ports, railway hubs, or land-based transportation hubs or airports. There are use cases at dispatch facilities, at sorting houses, at packaging facilities. All over, there is a need for these critical building blocks that 5G has to offer. Jean-Michel, we can go on to the next one. Now, this chart essentially shows that from a worldwide adoption standpoint, there is already recognition that 5G has these capabilities, and therefore operators and regulators in pretty much all geographies in the world these days are looking at allocating more and more spectrum for this technology to be able to perform at its best. Thus far, what has typically happened is whenever a new generation of cellular technology comes into the market, it replaces the previous one gradually and reuses spectrum that has thus far been made available for cellular communications. With 5G, though, there is this renewed interest in offering such high data rates, such low latencies, that spectrum assets suitable for such uses are being sought after and are being allocated for use by operators worldwide. Next slide, Jean-Michel. So as I was mentioning a few moments back, the applicability of 5G into all these verticals is becoming very clear. Naturally, this is piquing interests among traditional cellular operators who want to diversify their business from serving the needs of average users on the street to starting to serve the needs of enterprises and industrial verticals as a whole. While their interest is naturally there, what's also happening is there is interest in non-operator entities wanting to set up their own networks. So there is interest in all sorts of users wanting to deploy their own custom networks, their own private networks for their own specific tailor-made needs. Now, the needs of different industry segments vary quite a lot. You know, it's very difficult to discern what a specific phone is doing at any particular time. The user might just be browsing, or the user might be watching a streaming video session of some sort. However, in industrial verticals, it's quite easy to determine that certain devices do certain types of activity pretty much all the time. For example, there are sensors whose job is always to sense for a certain key physical parameter and report back whatever readings have been noted. Whereas there are other devices that perhaps are security cameras that are pretty much all the time just recording video and streaming that to some sort of a server at the back end. Now, given such distinct, well-known uses in these verticals, it's very easy for networks to be deployed in a manner where they can be tailor-made for these applications, and the exploitation of technology can be further upped to benefit the use case the most. As a result, private networks where users of such networks can control the destiny of these networks and really optimize their performance to suit precisely what their needs are, such networks are on the rise. We are seeing such networks being sought after in venues, at ports, in manufacturing facilities, in medical establishments. All sorts of atypical users are now trying to exploit 5G and see how best to improve performance of their own use cases using this new technology. Next slide, please. So to understand why private networks, and specifically 5G private networks, are growing in interest. Essentially, what this does, like I mentioned, of course, they can be tailor-made from a use cases standpoint to serve the needs the best from a performance standpoint. In addition, it can be this technology can be designed to serve the needs of security and privacy as well. With private networks, users of such private networks can architect their network in a manner where data that is relevant for their use cases and that is critical for their use cases never leaves premises at all. They can host the network in a manner where gateways can be self-contained within their network premises itself, thereby ensuring that all mission critical data remains within their control all the time. This inherently brings in privacy. This also allows them to use security features within 5G to protect their assets, their physical as well as data assets, from breaches that might happen from the outside. So the need for privacy is another aspect that's growing along with use cases such as Industry 4.0. Naturally, mission critical applications such as factory automation or such as hospital operations are things that more and more are becoming pretty much critical, to the point where failure can result in complete loss of revenue as well as complete disruption to business, not just for days, but perhaps for several weeks to follow. So that's another key reason why private networks are being looked at, specifically in the context of 5G, because 5G has the ability to secure communications more than prior generations of technologies have been able to. Next slide, please. When it comes to private networks, I think we can click to the entire. When it comes to private networks, naturally, the interest is in owning and operating the entire network on their own. So, for example, if a port were to deploy a 5G private network, they could deploy their base stations, their radio equipment, their antennas all themselves. They could deploy a core network that would handle all the data and handle all subscriber related information themselves as well. However, this naturally requires the ability to be able to manage such networks once they are deployed, some degree of familiarity in terms of what this technology entails, and some degree of 5G awareness when it comes to day-to-day operation. While this is the most suited use of private networks, and this is perhaps something that most private network operators are seeking, it's important to realize that there is another flavor of offering private networks to end customers as well, whereby radio assets alone are managed and operated by the private network customers. For example, in a port-like setting, the port might want to plan out their radio network alone, yet have subscribers managed by a public operator that already offers cellular services in the area, thereby ensuring that management of subscription, management of certain aspects of the network operations itself that go beyond just providing coverage to assets that need coverage, those things can be offloaded to a mature traditional operator that not only offers benefits in terms of OpEx reduction or OpEx simplification, that also allows for assets to roam freely back and forth between the private network and the public network. For example, if there are mobile assets at a port location that require reliable communications while at the port itself, that's something that the private network part of the network would be able to offer. But if such assets do need to, from time to time, roam in and out of the geographical area where the network provides coverage, then having a mechanism where a public operator is managing subscriptions would allow for roaming in and out of the private network itself. Again, these aspects, these degrees of freedom become relevant depending on use cases that one is trying to address. A key point to note here would be that for anyone who is trying to deploy and manage a private network, they would really have to pay attention to what type of devices are going to be accessing these private networks. Are these devices going to be equipment that are fully controlled by whoever has deployed the private network, or are devices from the outside going to roam in and out of the private network and might from time to time need to access the private network itself? Depending on all of this, such considerations would become important. Is the private network operator managing subscriptions entirely on their own, or are they relying on a public operator to manage subscriptions so that roaming of devices in and out of networks becomes easy? In a port-like example, for example, if you were to look at vessels that roam worldwide, if ports were private networks, individual ports would need to know the vessel, its credentials, something like a SIM card that's being used in the communications terminals inside the vessel. These would be pieces of information that private networks at various ports would have to know a priori. However, if such private networks at ports were relying on public operators to manage subscriptions, then pretty much the existing infrastructure that handles roaming-like use cases where users travel from one country to another and seamlessly seem to get data access, such fabric that's already in place could be relied upon, and use cases such as ports could potentially benefit from piggybacking on the fabric that already exists. When it comes to private networks, another key point to note is there is global recognition now of the benefits of 5G for such use cases, where various countries and regulatory bodies are earmarking spectrum assets specifically for use by such applications. For example, here in the US, there is spectrum allocated in the 3.5 gigahertz band. It's referred to as the CBRS band, which specifically is made available for users such as factories or schools or hospitals who might want to set up their own private network. They don't have to rely on a public operator to make spectrum available for such use. They don't have to rely on ISM bands or unlicensed bands, such as the bands used by Wi-Fi to deploy their networks either, because those bands inherently are a compromise when it comes to reliability. So with such spectrum earmarked for private use, what happens is operators who want to deploy such private networks are able to use such spectrum. Non-operator entities, such as large consulting houses, just to take an example, perhaps the IBMs of the world or the Accentures of the world, they can simplify the process of making 5G available to end customers by starting to deploy networks themselves. Spectrum is no longer something that they have to contend for because it becomes freely available increasingly for such specific use. Next slide, Jean-Michel. I think that was
okay.
about
So
it.
I think I'm going to take over unless there is any question at this point.
Thank you. There's a few questions, I think, popping up in the chat box, but I do believe that we can probably take them holistically at the end of the session. Do you agree,
Okay.
Ernie?
Yeah, I have no problem with it.
Okay.
Okay, so sounds great. So let me move on to cellular positioning and especially 5G and our positioning, right? So the wireless industry has been working on wireless for more than 30 years, as you know, and cellular positioning has always been an industry consideration, right? For every single new generation, every new G. Positioning was always taken into account, right? And as you see, the accuracy that was possible with the various generation has tremendously evolved, right? From kilometer level in 2G, right? We went down to the high hundreds of meters in 3G, down to the low hundreds of meters in 4G. And what you see here is 5G is actually a little bit of a breakthrough when it comes to positioning, because now we're talking about meter level or centimeter level positioning, right? And I'm going to spare you the the pain of having to hear about all these acronyms here. I will cover some of them, but not all of them. But all these things are the cellular positioning technologies that have been standardized over the years since the 2G days, right? So let's talk a little bit more about 5G and what is it that makes 5G interesting from a positioning point of view, right? So I think Shyamal talked about this, right? What 5G introduces is this flexible, scalable bandwidth, right? So in 4G, we were pretty much limited to, 10 and 20 megahertz bandwidth type signals, right? With 5G, potentially you can have access to, several hundreds of megahertz, right? So the result of this is, when you do time of arrival for positioning, right, now you have a much more robust time of arrival because you have access to a much wider bandwidth. And, what applies to GPS and GNSS, and I'm sure, most of you know that, right? The wider the signal bandwidth, the better job you can do at positioning, because the better job you can do at measuring the signals. And what you can do is you can better reject, what's called multipath, which is, these undesired reflected signals that actually corrupt the positioning process, right? So the bandwidth is a big deal. This access to the super wide bandwidth is a big deal that gives us very robust time of arrival, right? Some technologies, and we'll talk about this on the next slide, but some technologies rely on what's called time difference of arrival techniques, right? Which requires precise, time synchronization between the transmitters. In this case, we call this the G node Bs or the the 5G transmitters, right? But some other technologies actually don't rely on this, tight network synchronization. But what we can do though is we can estimate what's called a group delay, and this capability that we have to properly calibrate and compensate the group delays for these signals to the nanosecond level is also what's going to allow us to do very precise positioning in 5G, right? So that's the first part. The second part here, and I'm not going to cover all this, but with 5G comes the deployment of what's called massive MIMO, right? So basically, G node Bs or cellular transmitters that support a pretty significant numbers of antennas, right? And with this, high number of antennas, you can do beam forming, right? And now you can start steering the beams toward the devices that you're trying to reach, and the devices can figure out which beam they are receiving or processing, and so does the G node B or the cellular base station, right? So, the deployment of this massive MIMO is also another reason why 5G can do a better job at positioning, because now we have access to, spatial diversity. We can look at, these beams and which direction these beams are coming from, and we can also combine this with the the time-based measurements that I talked about before, right? So if I delve a little bit more into the details, right? So these are all the positioning methods that have been defined in 3GPP release 16, right? So these are not Qualcomm positioning methods, right? This is fully standardized by 3GPP in release 16, right? So obviously we have the traditional cell ID, right? Basically, which base station am I talking to? There is also the enhanced cell ID, right? If you start listening not only to the serving cell but also to the neighbors, you can do some trilateration between these cells. But the accuracy you're going to get with cell ID is not going to be great. It's going to be in the hundreds of meters or sometimes more, depending on the network density. right? So the other techniques that we have, right, we have what's called downlink TDOA. TDOA stands for time difference of arrival, and you have the counterpart, which is the uplink TDOA. It's also called RTOA, right? So these again leverage this super wide spectrum that you have access to, and by doing that you can measure the distance between the transmitter and the receiver, and by applying some traditional trilateration technique, you can compute position, right? There are pros and cons with every single one of these location technologies. One of the cons that I want to bring up here that I believe is relevant to what you guys are interested in is, this time difference of arrival techniques actually rely on the fact that the transmitters have to be very, tightly synchronized, right? And remember, we're talking about meter level positioning or sub-meter level positioning, or in some cases centimeter level positioning, right? Remember, 1 nanosecond is 3 meters, right? So if you want to get down to the sub-meter positioning, you'd better have some pretty good time synchronization. And typically the way these networks are synchronized, you can buy a super expensive atomic clock and hook it up to your network, but it's not economically viable, right? But the other solution you have is connect your transmitters to a GPS or GNSS receiver that can produce good timing, right? You have potentially you can leverage the so-called 1 PPS, 1 pulse per second, right? And basically synchronize your network, right? So these TDOA techniques typically rely on precise time synchronization of the network, right? Which, if we're using GNSS or GPS as the timing source, that can be a problem if GNSS gets jammed or spoofed, right? So I'm sure somebody was going to ask the question, so wanted to mention this, right? So these are the TDOA techniques, right? There is also the so-called MC-RTT, right? So MC-RTT stands for multi-cell round trip time, right? And in this case, you're not doing time difference of arrival, right? But you're doing round trip time estimation between the device and the G node Bs, or the cellular base stations, right? And the beauty of this technique is, because you are computing a round trip time, right? The network doesn't need to be tightly synchronous, right? So you no longer need to rely on this super tight synchronization. It's okay if GNSS gets jammed and spoofed, right? The performance should remain the same, right? So RTT, now you can do trilateration, assuming you have enough measurements with enough base stations, and you can compute position. The other technologies or location methods that I started to introduce before, these are the methods that leverage spatial diversity, right? So basically, leveraging this massive MIMO deployment and the fact that the cellular base stations are now broadcasting beams, right? So, and of course, the more antennas you have on the G node B or the base station, right, the more beams you can form, right, and potentially the narrower these beams are, which means that the better accuracy you can get by leveraging these beams and decoding the signals in these beams, right? So you have two different types here. There is one that's called downlink AOD, right? So downlink angle of departure. In this case, the mobile device, right, the receiver. You figure out which beam it's communicating with, right, with precision. And in the case of this uplink AOA, angle of arrival, in this case, this is the G node B or the cellular base station that determines from which direction of the sky or which direction of the half sphere it's receiving a signal from the mobile, right? So these are the these are the 6 major location methods defined in 3GPP Release 16. What's interesting also is you'll see, you can combine these, right? And there is actually a lot of benefits in combining some of these, and we have actually some results to share with you. Okay, so what I'm sharing here is the results of a technology trial. By the way, this is public information, right? So we don't mind sharing with you. So it's a trial that we've done with one of our major partners in China. In this case, the company ZTE. And what we did is we evaluated the potential of RTT and AOA, right? So you see round trip time and AOA. You see the deployment. In this case, you have, I think you have 5 cells, right? This is in 2.6 gigahertz band. There is a number of antennas. And the accuracy that we got here was actually pretty impressive. It was in the single digit meters or sub-meter, right? Especially if you do multi-cell positioning. What was interesting to us as well is there was great accuracy on the vertical dimension, and that's mostly thanks to the spatial diversity and the angle of arrival. We've done similar tests. I'm going to almost skip through this, right? We've done similar tests indoors, right? Actually in this building, and we saw also some good performance, right? Basically, less than 10 meters horizontal accuracy and about 2 meters vertical accuracy. This is not a use case that's relevant to you guys and the port environment, but it's interesting to see how the accuracy evolves with probably multipath and obstructions and these kind of conditions. Okay, so we added these 2 videos. I'm not going to cover these. We'll send you the slides. You should feel free to click on this. This is public information, right? This is stuff that we announced actually at the Mobile World Congress a week and a half ago. And just for you to understand the benefit of the technology, we have 2 different cases here. There is the wide area positioning, leveraging the macro network deployment, and then there is the indoor industrial positioning use case, right? And what you'll see if you listen to these videos, you'll see that there's a wide range of performance you can achieve depending on which technology you use, depending on which signals are getting used, depending on the bandwidth, right? And you see you can get down to the centimeter level positioning up to tens of meters if you're using some devices that are narrowband and under certain conditions. Okay, so I'm sure the question of coverage and accuracy is going to come up, right? And so unfortunately, right, the port environment is not a use case that we've been focusing on, right? And that's just something we're starting to look into by to you guys is there is flexibility, right, in how you configure the network and the device, right, to produce the type of coverage and accuracy that you need for the use case of interest, right? I was curious a couple of days ago. I looked up, different ports, right? And I think I got this one from you, Ernie, Port Headland. That's a very interesting port, right? And I think for this one, I can see how probably a macro deployment, right, carrier deployment may, meet the needs may meet your needs, right? But if you look at the port of Marseille in France, right, very, I would probably bet that the cellular base stations are probably pointing towards the land as opposed to pointing towards the sea. Probably there is probably some coverage as well, but I would suspect that the deployment of the network here is not optimized for communication at sea and not optimized for positioning, right? But there is a number of things that you can do, especially if private networks get deployed. You can play with the network topology, the frequency of operation, right? You can adjust the TX power of the G node Bs and receiver sensitivity. You can play with the antenna configurations. And then we have this PRS, right, the positioning reference signals. These are the signals that have been defined specifically for positioning in 3GPP, right? And the way the the density of these PRS signals and the repetition factor of these PRS signals will also play a key role in the hearability that you have of the G-node base and the accuracy that you will get in the end. There is also this thing that's called muting, which is a concept when the base stations actually shut down, so to speak, to minimize interference and maximize hearability of at a particular device of the the rest of the base stations, right? You can also play around with this to maximize performance, right? On the accuracy side, of course, there is the same things. You can play with the cellular network, right? There is also the concept of geometry, right? Dilution of precision, the exact same concept as the one we have with GNSS, right? The more satellites you have and the farther apart they are, the better the accuracy. It's going to be the same with the cellular positioning, right? So you could definitely optimize the distribution of the cellular towers for positioning, right? And of course, multipath and reflectors will be a key part. I suspect, we don't know for sure, right? But I suspect that in the port environment, the multipath will probably be much easier to deal with as opposed to the urban canyon, which is the environment that we focus on most of the time. Okay, so I see we are almost running out of time. This is my last slide. Very quickly, this is where we are today, right? Release 16, and we see that meter level positioning is being demonstrated by the industry. I think the entire industry is already working in release 17, right? And we see and we've actually demonstrated that 3D centimeter level accuracy is achievable as well under some conditions, right? And of course, there is this 3GPP release 18 and beyond. There is a number of improvements that are being planned right now. Improvement for positioning performance, right? Improvement to support, cheaper, more narrowband devices. This is what this NR light positioning is about. The one that I wanted to bring up with you, and we should probably rediscuss that at some point, is this concept of side link positioning, right? So 3GPP release 18 defines the way that these devices can actually talk to each other out of band without going through the cellular network, right? And because signals can be exchanged between devices, you can also do positioning between devices and relative positioning and distance measurements, right? So that's something that may be of interest to you, especially in the context of ship-to-ship communication or ship-to-ship positioning or floating buoy to ship type positioning, right? So this is the last slide that I have. I think it took a little bit longer than I thought. We have 4 minutes for questions.
Thank you. I've just put a little note in the chat box. If people are willing to stay for another 10 to 15 minutes, we could address some further questions. I know that there are a number. We do have another session that we were going to look at this in a bit more detail, but we were thinking of using the presentation, but we might also invite you. It is at a similar time, so we'll confirm that later. But are participants happy with another 10 to 15 minutes? Just show me with a thumbs up if you are. Otherwise, we will take note of the questions that have come in the chat box.
Let me check on my side as well, Gian. That's okay with me. Kiran and Shyamal, can you stay another 10, 15?
I'll have to drop off at 2, Jean-Michel, maybe a few minutes after 2.
Okay, so questions.
I can stay back. I can stay back.
You have 3 minutes, Kiran. Any questions for Kiran? I will have one question that's in the chat box, actually, and it's, I think, Kiran, because it might be suitable for you, you did make the note about 4G is expected to persist. We have had yesterday discussion on 2G and 3G being switched off by some network operators. Mm-hmm. And there is a question as to what this might mean and how that will fit, how long is 4G and 5G. So we do have that response in there about 4G for at least another decade. Do you have any comments on 2G and 3G?
So with respect to 3G, again, Shyamal and Jean-Michel, you can also pitch in based on what you're seing on the product side and also the operator engagement. Actually, I'll let you go first if you have something to add on that, and then I can do it too as part of the operators discussions that you're seeing. Anything you'd like?
I don't have anything special. My understanding is 2G is being phased out for sure, right? 3G is also being considered, but I think it goes carrier per carrier. But yeah, I don't have any specific information on the phases out.
Thank you.
That's
Yeah.
it.
Me
Go.
neither. Me neither. But at least let's put it this way: 3G phase out has just about begun. What that translates into for 4G, at least, is no one's talking about it. And I think Kiran was the one who had responded, right? So a decade at least for 4G, if I were to guess anything.
Yeah. So, and typically what happens also is, even as the next generation is coming in, a few years after the next generation comes in is when the previous generation actually peaks. So we probably haven't even seen the peak of LTE. So and same was the case with 3G, because that's exactly where it also starts getting into some of the developing markets as well. So in terms of the volumes of shipments and all of that. So yeah, 4G will have long legs. It's going to go on for a while.
Thank you. Yes, no, I think the concern that we have right now are 2G and 3G, because in the port environment, and shipping environment, there's sometimes it takes quite a while to refresh all of the systems that we have there.
Yep.
There is a question from Minsu about the satellite component of 5G. Could that support the solution for the coverage issues? So how is the satellite component of 5G fitting into this?
So I'm not sure what you mean by satellite component of 5G. So these 5G networks, and by the way, Shyamal, you feel free to jump in as well, right? So these 5G networks are typically synchronized for communication purposes, right? And I think the carriers who are thinking of deploying for positioning purposes may or may not, right, synchronize even in a more tightly fashion to support precise positioning, right? But remember what I said, right? Some techniques requires tight sync of the G node B, some don't, right? So I think when we go to operators and tell them you may not have to synchronize your network to benefit from 5G positioning, I think they actually like it, right? It's music to their ears for those of them who haven't done that in the past, right? But there are some carriers who've done that in the past, who've deployed 4G positioning that requires also tight network synchronization. These carriers actually don't mind. So and the time synchronization, sorry, going back to the satellite part of the question, right? The time synchronization is typically done through GPS or GNSS. So I don't know if I answered the question.
Thank you, that's fine. And I guess one of the issues that we've been having with GNSS is also the vulnerability of GNSS. So by relying on timing from GNSS, so also looking at alternatives or ways to address the spoofing, jamming issues within GNSS.
Right. Yeah. So if I don't know, if a port deploys, technology that doesn't rely on time synchronization, then I think that pretty much isolate, this 5G NR positioning from GNSS spoofing and jamming.
Yes, I think you did provide some examples there as well, where we don't need to rely on the timing for the positioning with other opportunities.
Yep.
There's a question from Ernie about the 5G positioning timing. Does it require G nodes to be synchronized to the GNSS system? And if so, when the GNSS systems fail and are spoofed, how long can they operate before? How long can they operate independent of GNSS? I expect is there a graceful degradation period?
Yeah. So Kiran, if you haven't left, you want to take this one before you go?
Yeah, sure. Yeah. So one of the techniques that you're talking about here, and also the demo that we showed, is where we don't rely on G0B synchronization across the network, which is, so this is our multi-cell RTT. So this is a solution based on round trip time measurement from each one of the G0Bs or cells. So there's an example where, we're not going to be highly dependent on GNSS. So one of the things we should realize is also depending on the spectrum that we're talking about, if it's a TDD deployment, time division duplex deployment, there is some level of synchronization that's needed in the network because we want the entire network to go downlink or uplink. But then this is very loose synchronization, not at a nanosecond kind of a level. And typically also with G0B solutions in cellular systems, the crystals that we have are quite stable. So they'll need a periodic sync, but then even if they lose GPS signal, for example, they can go on without without letting the time drift to an extent where the system actually starts falling apart for several hours, or again, depending on the requirements, you could even stretch it into days as needed. So there is quite a bit of robustness built in as well. And it also goes back to Jean-Michel's earlier comment about even based on the requirements of specific applications and deployment, some of these things can also be fine-tuned. So that's something to take into account as well.
Thanks, Kiran. So I think what you said is, the system is designed not to completely collapse as soon as jamming, spoofing happens, right? There may be a graceful degradation, but over hours or days, probably.
That's right, yes.
Thank you very much for that. Are there any other questions? I have just gone through all the ones in the chat box. Are there any other questions? Does anyone else have a specific question they wanted to ask? Thank you, Wusong. Are there any technical differences of positioning by 5G between independent and integrated private architecture? Speaking about the problem of the primary authority of deciding a position privately or publicly. So yeah, go ahead, Jean-Michel.
Yes, sorry, I was reading the question again, especially the problem about the primary authority of deciding position. I don't think there is any fundamental differences between 5G positioning on public or private networks, right? The same location methods are being used, the same technology applies. And then I think the end of the question, primary authority of deciding a position of UE, privately or publicly. Okay, so I think you're alluding to probably privacy and how the location gets shared, right? So the same problems happens whether it's a private network or a public network. When you deploy 5G NR positioning, you have three major entities involved. Right? There is a device or a mobile device. There is a the G node B or the cellular tower, and then there is a location server that kind of orchestrates or coordinates everything between the device and the cellular tower, right? So there are multiple flavors of positioning that can be deployed. You have what's called, it could be UE based. We call this UE based in 3GPP terms positioning, where the position is actually computed by the device, and then it's up to the device to keep it or share it with other entities. There is another flavor of positioning that's called UE assisted. It's UE assisted in the sense that the device actually makes the measurements and assists in the positioning process, but the positioning is done by the location server, right? So in this case, the position is computed by the location server, and that's where it is. And then the location can be shared or not with external entities, depending on what the rules are for that particular network. Right, so these are the flavors. Privacy, basic privacy rules apply either way, whichever configuration, and fundamentally it's the same between private and public deployments.
Thank you very much. And I'm also looking at the time. So we did ask for, say, 10 to 15 more minutes. We're almost there now. Are there any final questions before I close out the session? And I do appreciate your consideration to stay just a few more minutes longer.
Sure.
So I guess then, just to summarize, thank you very much for the presentation and the information that has been provided, especially interested with some of the technology capabilities. I would like to confirm, you said that 1 nanosecond equals 3 meters, is that correct?
Yes, I think so.
Okay, I think Ernie, can you just confirm? I had heard it was 0.3 of a meter, so maybe I was misunderstanding some previous information.
Gillian, I take this back, I'm sorry. It is 0.3 of a meters, right? Yeah, 0.3 meters, 30 centimeters. My apologies.
Okay, thank you. So I just wanted to confirm that because I was a little bit surprised when I heard that number.
Yeah.
I think it might have just been there's a decimal place missing there.
Yeah.
So thank you very much for the presentation and for the concepts of what we can do. The next steps in this discussion for the working group is that we are looking at this as one of our new technologies. We do have a technology template to review and to complete, so I believe we'll start putting it into that format. And yes, Wusong, you've just raised your hand, and I did see it this time. Much better than you.
Thank you, Julian. May I have questions?
Yes.
Okay, thank you for a great presentation. And I have a question about the future plan or expectations of 5G release 17 or 18. As I heard your presentation, release 17 or 18 have very interesting features about the making a decision of locations. So do you have any time schedule or expectations implemented by the release 17 or 18 in the very near future, I hope? Do you have any schedule or expectation?
So you're asking in terms of commercialization timeline, right?
Yeah, right.
Yeah. So I cannot comment on this from a Qualcomm point of view because this is a public presentation we're making right outside of an NDA. What I can say is I think release 16 is done, right? And in general, what I see is carriers worldwide are starting to think about deploying release 16, probably later this year or next year, right? And I can see how release 17 would follow right after that. And again, I'm not talking about what Qualcomm plans to do, but I'm talking about what I see on the industry trends. I think release 18 is probably a couple of years down the road, 2-3 years down the road. That would be my guess.
Okay, thank you.
Sure.
Thank you very much. And just to let you know, Wusong, your hand is still up. We do have this issue. We put our hands up and we keep leaving them up. Thank you so much. So what we will need to do now, I think, is from our excuse me, from our working group point of view, is to consider this information that's been presented. It's been a very interesting presentation. Many notes of thanks that are coming in on the chat box as well. We need to think about how this fits within this concept of a public and a private aspect. You've given us a lot of food for thought on the private deployment. We have had previous discussion also with regards to public and commercial. We do have a template for technology as a whole. So as we're looking at the differences in the developments in 3GPP, we've been reviewing that. So we do have a session from our point of view, from Working Group 2's point of view, we have a further session that is set for reviewing new technologies on the 21st of March at the same time zone. I guess between now and the 21st of March, I would ask the committee members, if you have any specific questions, please pass them by me. I will email them to Jean-Michel and Shyamal. And then we will also see about any further steps that we have within our discussion areas. We do also need at that meeting to review, oh no, we're looking at the review of the other technology on the 22nd of March. So on the 21st of March, we will have a further session at the same time zone to review and digest the presentation that we've had here. Ernie, do you have any further comments on that? I think you're leading that session.
I am, and I don't think there's anything that we need beyond what you said. It's just a broad discussion, and we need to decide what are the two sets of next steps. Really, what are our next steps going to be, and then do we need to go back to Qualcomm and or others to get the next steps from the industry side?
Okay, thank you so much. So thank you very much, Jean-Michel and Shyamal. And to all members, if you have any questions, please make sure you email them through to myself and Ernie, and we will forward them on. And we will also bring those responses that we may get between now and the 21st to the next meeting, where I think we'll also have a lot of questions.
Sounds great. Thank you very much, Jillian and Ernie. We appreciate the time, and please let us know if you have any questions for us.
Okay, thank you very much. It's been a pleasure to have you, and thank you everyone for remaining those extra few minutes. It's a very interesting topic, and a topic that we have been looking at now for a few years with regards to 3GPP. So thank you everybody, and have a very good morning, afternoon, or evening. For me, it is now, the sun is up again, and I'm about to go have my breakfast. So have a good day, everybody.
Right. Thank you very
Thank
much.
you.
Bye.
Goodbye.
Thank you.
Bye-bye, everybody.
Thank you.
Thank you.
Bye-bye.
Bye.
Thank you. Bye.